All right, Algebra 2, we are going to work further on section 2.7, part 2. Talking about now complex conjugates. So also in example 2, notice that the zeros, 2 plus I squared root of 3 and 2 minus I squared root of 3 are complex conjugates. Notice they're the same, they only differ in the plus and the minus. This illustrates the first theorem given below. A similar result applies to irrational zeros of polynomial functions as shown in the second theorem below. So let's talk about the complex conjugates theorem. If f is a polynomial function with real coefficients and a plus bi is an imaginary zero of f, then a minus bi is also a zero of f. Often you'll see when they list zeros, like, I don't know, let's say there's a -1, a 2, and a 2i. That's all they list. You also need to make sure you know that a -2i is also a 0. Okay, this means that x plus 1, x minus 2, x minus 2i, and x plus 2i are all factors of that polynomial. Moving on, irrational conjugate theorem. Suppose f is a polynomial function with rational coefficients and a and b are rational numbers such as square root of b, such that square root of b is irrational. If a plus square root of b is a 0 of f, then a minus square root of b is a 0 of f. That just means that if we're left with zeros like when the book lists -1, 2, square root of 2, you also need to know that negative square root of 2 is also a 0. So we would list x plus 1, x minus 2, x minus root 2, and x plus root 2. Okay? Write a polynomial function f of least degree that has the rational coefficients, a leading coefficient of 1, and 3, and 2 plus square root of 5 as zeros. So this is a tad bit tricky, but we know that 3 and 2 plus the square root of 5 are zeros. So that means I would have x minus 3, x minus 2 plus root 5, and x minus 2 minus root 5. Because we just said whenever you have this as a 0, it includes the 2 plus and the 2 minus. Now we need to come up with a polynomial. So what I'm going to do, I'm going to write this one again. I'm actually going to group the rational numbers, x minus 2 plus root 5 and x minus 2 minus root 5. I'm going to do that every time I have a complex conjugate pair, right? Now we've learned, I'm going to write that again. What I have here is a term plus a term and a term minus a term. This should multiply into the difference of perfect squares, which we have learned already. I'm going to do this in blue and this in green, just to help us see it. So what I'm going to see here is x minus 2 squared minus square root of 5 squared. Notice I just keep on rewriting that x minus 3. X minus 2 squared is really x minus 2, x minus 2, minus square root of 5 squared is just plain old 5. Again, x minus 3. X minus 2 times x minus 2 is x squared minus 4x plus 4 minus 5. So that's where we are right now. I ran out of space. I'm going to simplify one more time. X squared minus 4x minus 1. Now I'm going to multiply these. I'm going for the box. You guys may laugh, but I find it easy. Okay, label the top and the side, and go ahead and multiply row times column. Okay, x squared times x, negative 4x times x, negative x, then I get negative 3x squared, 12x, and 3. Go ahead and collect all my like terms. My answer is x cubed minus 7x squared plus 11x plus 3. There we go. So write a polynomial function of least degree that has rational coefficients. A leading coefficient of 1 is important, and the given zeros right here. So what I see here is x plus 1, x minus 2, and x minus 4. Okay, these are the easy ones. There's no complex conjugate pair. So I'm going to go ahead and FOIL the first two binomials. X squared minus 2x plus x minus 2. Notice I'm going pretty quick on these nowadays because we've done this for quite a few lessons, and I'm just barreling on through, right? So that's where we are right now. I'm going to move to another page and finish it. So that's where I was last slide. Set up a box. It's a rectangle. It's like I'm calculating the area. Label the row and column and multiply row versus column. Okay, row versus column. That should be plus. Every once in a while I get a little too fast, right? So we have f of x. I don't think I labeled the last one f of x. We should label it f of x minus, that should be cubed. That would be x cubed minus 5x squared plus 2x plus 8. Cool. All right, let's do another one. Here I have 4 and a complex conjugate pair. So the 4 is easy. I do x minus 4 and then x minus 1 plus root 5 and x minus 1 minus root 5. Okay, let's pay attention because I group things, right? I do x minus, x minus 1 plus root 5, and then x minus 1 minus root 5. Yep. I'm still going to just keep copying that x minus 4 until I'm done. Now I do first, I'm going to FOIL this. So really I'm doing first times first, outer, inner, last. If we remember, say this again, this is like a difference of perfect squares. So this first term plus the second term and minus the second term. So the difference of perfect squares, you should remember how to do this. I get x minus 1 squared minus square root of 5 squared. So that gives me x minus 4 x minus 1, x minus 1 minus 5. So this is where we are right now. Just copy that from the last slide. I'm going to multiply this, FOIL it, x squared minus 2x plus 1. That is plus 1 minus 5. X minus 4 times x squared minus 2x minus 4. Okay, let's multiply those. X minus 4 on the left, x squared minus 2x minus 4. Fill in the squares, multiply row times column. Keep going. And we can write our answer. X cubed minus 6x squared plus 4x plus 16 equals f of x. That f of x can go in the front. Here we have quite a few zeros. I have 1 0, 2 and 3 zeros, and 1, 2, 3, 4, 5 zeros. I have 5 zeros. So what I have here is x minus 2, which is that first one, x minus 2i, x plus 2i, x minus 4 minus root 6, and x minus 4 plus root 6. This is going to be fun. Let's go ahead and work on this one. Remember, when I have minus and plus, when I FOIL those, I'm going to get the difference of two squares. So x squared minus 2i squared. X squared minus 4i squared. Reminder here, I squared equals negative 1. So x squared minus 4 times negative 1, x squared plus 4. And keep on copying this down. I know it's silly. Cool. Okay, I'm going to take this. Well, I can work on it now a little bit, can't I? All right. So first I'm going to regroup. Remember, x minus 4 minus root 6. X minus 4 plus root 6. So again with this, I've got plus and minus. This is the same, and this is the same. So what I'll see here is x minus 4 quantity squared minus root 6 quantity squared. Okay, x minus 4 quantity squared is x minus 4 times x minus 4. So x squared minus 8x plus 16 minus square root of 6 squared. So that gives me x squared minus 8x plus 10. Whew, need a new slide. So I'm at x minus 2, x squared plus 4 x squared minus 8x plus 10. So let's go ahead and FOIL these. I have first times first, x cubed outer, inner, and last. Simplify that or put it in the right order. And we can multiply that by this. But to do that, I need to set up my boxes, which I'm going to do with a new slide because I'm totally going to run out of space. All right, I grabbed the polynomials from the last slide and wrote them in a area formula here. So rows times columns, x to the fifth minus 2x to the fourth times 4x cubed minus 8x squared minus 8x to the fourth plus 16x cubed minus 32x squared plus 64x 10x cubed minus 20x squared 40x and minus 80. Whew. Collect like terms. F of x equals, let's see, x to the fifth minus 10x to the fourth. See, I have a 10, a 16, and a 4. This is 20, 30 x cubed, negative 52, negative 60 x squared, and then 104, and then minus 80. Whew, that was long and correct. Nice work. All right, if you would like to try this one, I feel like we've practiced quite a few. This will be 3 minus I, and 3 plus I. And my answer is going to be f of x equals x cubed minus 9x squared plus 28x minus 30. Cool. All right, approximating zeros. All of the zeros in the function, and we didn't do example 4, but all of the zeros in any function are irrational or imaginary. And I can't say are, but could be irrational or imaginary. Irrational zeros can be approximated using technology, using your graphing calculators. So if we look at this, the instructions say approximate the real zeros of this function. I should have 6 zeros altogether, but we can use the zero feature of a graphing calculator as shown below. We would do second calc and select the word 0. Please ask in class, and I would love to step through this with you. But when we type in a function, y1 equals x to the 6th, etc., we can do second calc and come up with a screen. And if you remember, it's going to ask you to, let's see, it says, if you remember, we've done it before, but it'll ask for a left boundary with a question mark, a right boundary with a question mark, and then a guess with a question mark. What we generally do then is we have our little spider on the left side, on the right side, and then it'll guess somewhere in between, and it'll spit out what the x value is where it crosses. And again here, okay, left boundary guess, right boundary, and then guess, and it'll spit out the 0. And this is just approximation because we're going to round it to a certain value, which is your approximation. Okay, guided practice. So here, I would go into my calculator and type in, not in yellow because yellow is hard to read, y1 equals this entire function. And then I would hit the second button, the calc button, and the 0, and select 0. The calculator will then ask me what the left boundary is, and I'll move that little spider to the left of the 0, what the right boundary is, and I'll move that little spider to the right of the 0, and then the guess. Oh goodness. And I'll put that little spider as close to where that function crosses the x-axis, and it will spit out x is approximately negative 2.2. X is approximately negative 0.3, and x is approximately 1.1. That means we need to do this 3 times. All right, this is our daily homework quiz, so I'm not going to work through these. Normally we would graph these. Unfortunately, I'm looking at this one and there are no rational zeros, so we're not going to solve it by graphing. So we'd have to find all the possible zeros with the negative 20. I get plus or minus root 5 and plus or minus 2i. Polynomial function with the least degree. There we go. I get f of x equals x cubed plus x squared plus 44x plus 150. Your daily homework quiz number 2, the book is incorrect. If you want to give me the correct solution to that, I will definitely give you a bonus point. Cool? Cool.